Welcome to qnawire.
Angular momentum about the pivot is conserved during this collision. So L before collision is equal to L after collision, and these are the angular momentum for the bullet and stick combination. So LB will be L before collision for the bullet plus angular momentum before collision for the stick, and the same for after collision. So we sum the angular momentum of both the stick and bullet for the final angular momentum. Now, since the stick is at rest, the angular momentum of the stick before collision is zero. Now we can write L. So L is basically equal to I times omega, and this is equal to mass times velocity times the perpendicular distance. And this comes from the expression R cross P. So let me, yeah. So L vector is given by cross product of R and P. So from here we can write the magnitude of L to be mass times velocity, which comes from the momentum, times the perpendicular distance of R. Now we can use this expression for the angular moment of bullet before collision. So this will be equal to mass of the bullet times initial velocity of the bullet times the perpendicular distance. So this is half, 1/4 of L of the stick. Let me just write L, and we can write L of stick afterwards. And this is equal to final momentum of the bullet, which is mass times the final velocity of the bullet times 1/4 of L. Exactly the same expression, but the velocities have changed now. And angular momentum of the bullet will be I times omega. Sorry, angular momentum of the stick will be equal to I times omega. So I of stick times omega. And from here we can write the expression for omega. So let me just write it in the next page. So omega will be equal to mass of the bullet times V naught minus Vf, basically change in velocity of the bullet, times 1/4 of the L over moment of inertia of the stick. And since the pivot is at the center of the stick, is passing through the center of the stick and is perpendicular to it, so moment of inertia will be equal to 1 over 12 mass of the stick times, oops, I'm out of space, so let me just write it again. So I'm using a different color. So I of stick is 1 over 12 mass of the stick times length of the stick square. Now we will use this expression over here. So we have mass of the bullet times V naught minus Vf times 1/4. Now L is basically length of the stick. So we write that, and we write the expression for moment of inertia of the stick. Now we can simplify this expression a little bit. So we arrive at this expression finally. Now we can substitute these values that we have into this equation, and we get omega to be equal to 3 times mass of the bullet. So make sure you convert the masses into kgs to be consistent with the units. V0 minus Vf is 110 meter per second over mass of the stick is 0.27 kg and length of the stick is 1 meter. We solve this and we get the angular velocity to be 3.7 radians per second.